Ever wondered how predictions are made in big data? In this vast digital universe, big data is the backbone of many modern marvels, from personalized ads to predicting market trends. Its potential is limitless, and yet it poses a unique challenge. How do we make sense of this mountain of information? How do we predict future trends? Enter simple linear regression, the unsung hero of predictive analysis. To unravel this mystery, we dive into the world of simple linear regression. So, what exactly is simple linear regression? Well, in its most fundamental form, simple linear regression is a statistical approach used to model the relationship between two variables. Here, we're dealing with a pair of components, a dependent variable, often denoted as y, and an independent variable labeled as x. In the context of simple linear regression, the dependent variable y is what we're attempting to predict or estimate. On the other hand, the independent variable x is the variable that we believe has some sort of influence on our dependent variable. To put it in simpler terms, think of y as the outcome we're curious about and x as the factor that we suspect might shape that outcome. The key goal here is to establish a linear relationship between x and y, enabling us to make informed predictions about future outcomes. Thus, simple linear regression is a method to predict dependent variable y based on the values of an independent variable x. Now, how do we use simple linear regression in practice? Well, let's begin with the first step, collecting data. Your data could come from a variety of sources, such as surveys, experiments, or even online databases. The key here is to ensure that your data is relevant to the problem you're trying to solve. For instance, if you're trying to predict house prices, you might collect data on factors like square footage, number of rooms, location, and so forth. Next, we identify the variables. In simple linear regression, we have two variables, the independent variable and the dependent variable. The independent variable, often denoted as x, is the predictor. It's what we believe might influence our outcome. The dependent variable, y, is what we're trying to predict. Let's move on to creating the best fit line. This line is a visual representation of our regression equation, showing the relationship between our variables. The goal here is to find the line that minimally deviates from all data points. This line is called the line of best fit or regression line. Now we need to calculate the slope and the y-intercept of our line. The slope gives us the rate at which y changes for a unit change in x. In other words, it tells us how much y will increase or decrease when x increases by 1 unit. The y-intercept is the point where our line crosses the y-axis. It's the value of y when x equals 0. Finally, we use our equation for prediction. We plug in a value for x and solve for y. This gives us our predicted value. Keep in mind that while this prediction will likely not be exact, it gives us a reasonable estimate based on the data we have. And there you have it. These are the fundamental steps of simple linear regression. From collecting data, identifying variables, creating a best fit line, calculating the slope and y-intercept, to using the equation for prediction. With these steps, we can predict future data points with relative accuracy. Now, how does this fit into the big data landscape? Simple linear regression is a powerful tool in the realm of big data. It's like having a crystal ball that helps us predict trends and future outcomes based on massive data sets. Imagine sifting through billions of data points, each representing a small piece of a larger picture. By applying simple linear regression, we can draw a line through this data jungle, and suddenly, patterns begin to emerge. This concept is not just an abstract theory, it's a practical tool employed across various fields. In finance, it helps forecast stock market trends. In healthcare, it aids in predicting patient outcomes. In retail, it assists in estimating sales for the upcoming quarter. The magic of simple linear regression lies in its ability to transform enormous complex data sets into understandable trends and predictions. It gives us the power to make informed, data-driven decisions. Simple linear regression, therefore, plays a crucial role in understanding and predicting big data trends. To sum up, simple linear regression is a statistical method that allows us to understand the relationship between two quantitative variables. We've walked through the steps, starting with plotting the data, determining the line of best fit, and calculating the slope and y-intercept. We've also seen how this powerful tool is applied in big data, assisting us in predicting future trends and making informed decisions. That's how simple linear regression helps us make predictions in the vast ocean of big data. Until next time, keep exploring.